Hi, folks. Steve Urban here from the Riderflex Podcast. Today's episode is proudly sponsored by two companies I'm deeply involved with. First up, Reliance, your trusted partner for nationwide robot maintenance and repair, specializing in humanoid and autonomous robots for homes and businesses. Visit roboreliance.com to learn more. And for all your home maintenance needs, there's Cura Home Maintenance of Colorado. From air duct cleaning to dryer vent cleaning to gutter cleanouts and much more. Check them out at curahomeservices.com. And finally, don't forget about the two books we've published in the Riderflex Guide series. The first being the Riderflex Guide, Inspiring and Hiring. This one is targeted at all types of managers and supervisors, anybody that interviews and hires people. And the second one, the Riderflex Guide 2.0, Mastering Job Interviews, designated to help all levels of job candidates prepare for and ace the interview. And now for today's episode. Please subscribe and enjoy. Let's get rolling. Where are you at today? Are you in Indiana or where are you traveling?
I'm traveling in Boston for Investor Summit. Presenting our technology and actively raising money. Yeah.
Okay. It's tough to run the company and raise cash at the same time, isn't it?
Yeah, it's like I don't know. The challenge is you're putting multiple hats. One day it's supply chain, the next day it's people management, and then fundraising to a general audience, right? So you've got to be able to adapt to those audiences, and that's the blessing and curse about the job.
Yes. Before we get into for Ateios and everything you guys are doing, um, I want to know about you, the person. Let's give the audience the story, family, where you grew up, mom, dad, all the stuff. Let's get some history in
Yeah,
here.
yeah. So I grew up in upstate New York. My parents moved here. They as soon as they got married from India, they moved here, and kind of born in upstate New York. My dad is a civil engineer. My mom's a nurse. That combination of kind of engineering and then also being able to execute from as a nurse, I think those skills have paid me off really well. I remember every time we were driving, my dad is a civil engineer, would ask me questions of like, why did they design the bridge like that? Why did those things? So that
Okay.
always, just always active curiosity mind. So yeah, I grew up in upstate New York. I think one thing is when I first started, actually, I was a big history buff. I wasn't actually going into science because I grew in the hometown of FTR. So I was enamored with all these politicians, kind of having huge
Uh,
impact.
I see.
And then I discovered actually, like right before I was going to college, that actually technology has a far more profound impact than compared to politics. And that's where I started shifting myself into science and engineering.
Why did you go to school in Southern California? Would you were like, I'm tired of the cold, or what happened?
No, it was just so after I did my undergraduate at SUNY Albany, which is one of the top semiconductor schools, there's this new generation of engineering called nanoengineering. So I had one of the first degrees there. And I could have continued doing my PhD in Albany, but it always recommended for PhDs to go to a different school, get a different perspective, new experience, build a new reputation. And so UC San Diego had the only other nano school. So there was a little bit of cachet of, being one of the world's first nano engineers, trained. So that and also working with the top professors at UCSD.
You're gonna have to tell the audience what nano engineering is, because a lot of people listening to the big, what the hell is he talking about?
Yeah, no problem. So basically, nanoengineering emerged basically in the 1990s, 2000s. Basically, the idea of that if we can manipulate material at the nano level, less than 10 nanometers, especially like the width of your hair, that's where you can enable a lot more innovative technologies. And the best example is semiconductor. So if you look at the transistor, each transistor that acts like a switch, right now we're at roughly, I think, 3 or 9 nanometer nodes. That generation size has continued to decrease every decade. It's been Moore's law. And so the ability to manipulate that and to make devices at that nano level allows you to build more compact, powerful devices. So that was the basis of nanoengineering. Now what they're trying to do is how do we leverage that know-how to build medical sensors for early detection, How do we build solar panels? How do we build batteries? So it was a really unique education where it was very multidisciplined compared to kind of focused biology, chemistry, and physics. We had to learn all three, and then also be really they trained us really well to apply manufacturing know-how, making sure yield, production, because that's the real impact of Moore's law. It isn't that you can double the chip, is that you can do that for everybody. So it's really enabling that Moore's law and impactful technology. That's maybe a little bit long worded of nanoengineering.
What were you thinking you were going to do? Were you like, I'm going to be a scientist? I'm going to be, were you thinking entrepreneur? What were you thinking when you were in school?
I think so. Basically, what happened is in school is I was initially going to be run for office or do
Yeah.
policy. I love
Yeah.
stuff. And then I did get into a pretty significant accident during my high school. So I roughly got slightly burned, 20-30% burns.
20,
So
30%.
on my face and arms there. So
I can't see. Is it?
yeah, a little bit here.
Ah, I see. Okay. All
So
right. How old were you?
I was 16, middle of high school. So
Let's take a pause right there because that obviously shaped your life in so many
yeah,
ways.
yeah, for sure. Actually, it's more detailed. It's like the challenge was is that they kind of damaged my trachea as well, so I had a complete stenosis. So I could not talk for a year. So it was definitely very
Oh, okay. Whoa. Let's all right. Let's just dive in here for a little bit here. All right.
sure.
So hold on. Were you a junior? How old were you? Or what grade?
I was a sophomore in high school. It was my summer, and then it was like during its campfire, got shirt, fire on my shirt, and
During a
uh,
campfire? Where were you at?
I was like in summer, so like during the summer camp kind of
Or
approach.
during a summer camp? Okay. I know you probably had to tell the story a million times. You probably get tired of telling it, but
Yeah,
um wow. You were like a bunch of kids sitting around the campfire?
yeah, just yeah. So
You didn't throw beer on it. Did you throw alcohol on it or something? Is that
I
what
just
happened?
stripped my shirt off. That's it. So
Damn. Okay. You were in the hospital for how long?
So I was about a year. So I actually was like usually burns you can get out within a month and it's just a lot of therapy. But because I had a complete stenosis of my trachea, basically the narrowing of my airway was completely clogged from scarring. So I basically was breathing through like a tube. It's called a trachea, basically they install to help breathe.
How'd you
So
eat? How did you eat?
could still eat, right? You could still eat. I just couldn't breathe through like there's two windpipes, right? When you're one is for eating, one is for breathing. So I could not breathe through my original upwear airway. I have to basically drill a hole here and breathe through that way.
Damn, bro. That's a tough age to go through something like that. I mean, really, holy cow.
Yeah, it was definitely tough. I mean, it's like I said, it puts a lot of perspective on the things that we're trying to do today, right? So yeah.
Right?
So
Because right when people are around you are like, "Hey, I'm having a bad day," you're like, "No, bro, you're not having a bad day. Trust me."
I know sometimes I have to take a step back. I'm complaining like, oh, it's so tough fundraising, and then I have to remind myself, where I was, back then. So it's always a good perspective. So
Damn. Okay, you couldn't talk for a year. Holy shit. Did you learn sign? What'd you do? Sign language? What'd you do?
no, I mean, I would write, I basically write and communicate that way. So probably could have been a good opportunity to learn sign language, but I didn't do that.
This is
So
not good on the dating life for a young man either.
nah, it's okay. So so
Uh,
you don't have to
wow.
try.
Okay. When you healed, did
Mhm.
you go crazy for a little while? Did you just go? You're like, fuck it. I'm just gonna party my ass off and go wild and go nuts because I'm well. I made it.
No, I think I took a different approach. I think I got more aggressive. Uh,
Which
you know, at school and kind of work so it was just because I was top of my class and I kind of a lot of
were
ambitions and
you?
I felt
I see. I see.
felt like I had I had it like where as soon as came back, like, I was a top athlete, top academic, basically all the way starting from the bottom and coming back up, right? Doing all those skills back and also, having to deal with kind of all the issues that have from the scars and so forth. So
Sure.
yeah,
Yeah. Sure. Yeah. Sure.
I think it
Did
was
you
the
ever?
perspective. Oh, sorry, what were you?
Did you ever give anybody the beat down because they made fun of your scars? Did you ever give anybody the beat down? I want to know about that.
I know I mean, I know people look, so there's always that, but it's not
They
like
almost can't help it, right? I mean, I don't know. Is that I don't know.
I mean, my business, I think my perspective, there's nothing I can do about it, right? So it is what
Yeah.
it is.
Yeah.
I mean, sometimes it can be freeing. I can, I know one time is like with family is like, kind of so tech and negative, but it also allowed me to make a lot of mistakes. I didn't have to be perfect all the time, right? I could do things. That's where it kind of setting the entrepreneur. There's, other challenges there, but I could take those risks, right? Because, it was a little bit freeing as well at the same time. So,
Interesting. 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 Okay. Well, I really appreciate you sharing the story. Okay. Thank you for doing. You're an athlete too, huh? Are you a big guy?
I mean, I was more short guy. I played soccer, so we're, more nimble. So yeah,
Okay. What happened to that soccer weight? What happened to soccer weight? You're not.
soccer way.
Are you married now or what? What are
Yeah, I'm
you,
married. Yep.
kids?
No, not yet.
Okay. How old are you?
I'm 33 right now.
Bet you didn't know you were going to get this personal on the podcast, did you? You thought you were.
Yeah,
You thought we were just going. You thought we were just going to talk business the whole time. That's boring. Who wants to do that? I mean, come
yeah,
on.
I usually like to be honest, I don't usually talk about this, so this is definitely new for me. So
All right. Well, that's one of the things we try really hard to do with the show is we want to make sure that the listeners understand that these CEOs and entrepreneurs are they're real people with real challenges and real families and real histories. I, I think so many times entrepreneurs will go on these podcasts or whatever, and they'll be like, "Look, well, we raised cash and we did this, and life's great, and yeah, anybody can do it. It's so easy," and then they give this false sense of reality, and it's like, no, 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 no. Actually, it's really hard, and we all have regular lives and speed bumps, and so I like entrepreneurs that will show their vulnerability and share personal hurdles. I think it's important.
yeah, no, I think I mean yeah, I kind of agree with that. I think, as much as I know we're trying, as a society, we're trying to be encouraging of entrepreneurship, but sometimes there's that lack of disclaimer of what you're going to go through, right? You go through difficult relationships, things that
Yep.
where you thought were best friends now becomes competitive because you have to do what's best for the business,
Yep.
right? So, and you don't realize it how hurtful it is until it actually happens, when you actually go through that and then you kind of quit, it's like, was it worth it, right? I think many entrepreneurs think of like going through the struggle, the relationships, trying to build, constantly asking, is it worth it? But then also constantly still driving, right? It's those two balancing, right? Keep going for the vision, but then reality sometimes is setting in, right? And how do you keep going? So I think I've had multiple experiences where I've had to deal with that, and that's made me really resilient. So
Yeah, you know how many times my wife has told me over the last few years, she'll be like, "Yeah, are you ever just going to get like a regular job so we have consistent pay and everything's going to go back to normal?" Like, no, no. I just tell her, I'm like, "No, I can't go back now. I stick needles in my eyeballs first. I can't."
I can tell you when I first started this company, there was like I was telling my parents how all these difficulties of trying to get contract and raising. The first thing was like, oh, why don't you just get a job, right? You don't have to deal with all this, right? It's like that's not the point, right? So. Yeah.
Uh,
At that point, I don't think I could have explained what was the point. So in terms of, why, uh, am I working so hard to do something where, there's so many barriers, right? So
give the story. Tell us about the company. Give the company overview real quick, and then I want to walk into some things. Go for it.
yeah, sure. So basically, out of my PhD, I was really enamored with the idea of that, with the semiconductor, they're using very expensive manufacturing to build, these huge billion-dollar factories. What I thought is, what if we could use printing technologies like newspapers, just like traditional printing newspapers, but apply that for solar, batteries, electrochemical sensors for diabetes. If you could do that, that's where you can actually, where it can be really scalable and have a real impact. So I was developing all these types of printed technologies like printed solar, printed batteries. And
When you say printed solar, you mean like a print, like a printed solar panel? What do you mean?
basically taking, so instead of traditional manufacturing is they take this metal and they kind of heat it up and sputter it or spray it onto a metal. So it takes a lot of high temperature and conditioning. My theory is like, what if you could take these materials, grind it up as like an ink, and then cast it as like a printing process? It would be so much faster. It wouldn't require so much, energy. You might not get the efficiency that you want, but that doesn't matter. It's actually more of a volume problem.
I see
And
what you
kind of
mean.
my and what was the driving force for me is, when you're doing a PhD, you kind of have to buy in, kind of like, why am I doing this? The motivating factor was if we want to build a really sustainable world, to power with solar panels, you need to cover the area of Iceland in solar panels. So it's not really for efficiency, it's a volume problem. And I just run the calculus for batteries. If you want to do 300 terawatts of batteries that's the Elon Musk's metric that we need to hit, you're talking about covering 7 Californias in battery material. So it's really a manufacturing challenge if we're going to hit these sustainable goals.
Wow. Okay. And you figure the printing, how does your printing solution fix that?
Yeah. So during my PhD, so actually, uh, we were got funded by ARPA-E, $5 million to build printing into clothing, like batteries into clothing, to develop, smart clothing for wearable devices. So I started the company doing that. It was the world's first printed stretchable battery. What happened is actually during that process, I discovered how inefficient the printing process is right now in batteries, where they use massive amounts of ovens and extensive amount of solvents to remove them. You've been talking about like 80 meters in a typical gigafactory. And this is where I was, what if we, just like printing, actually used a light-based process where you could just cure it with a flash of light. It shrinks the factory to a fraction of the size, increase output, and eliminates all those toxic solvents. So it's much faster, lower cost, and more sustainable way of manufacturing these batteries.
Okay, you're gonna have to explain it to me like I'm a 5-year-old.
Now, I'll see. I'll try again. So here, this is a better example. So, see here, this is an 18650.
Okay.
There's about 7,000 of these in a typical Tesla. So, but a lot of people don't know. Oh, what were you gonna say? Maybe I
Yeah,
can
yeah,
start
go
over.
ahead. Now I'm with you. Yeah, well, I like this. I like this example. Go ahead.
Yeah, so there's about 7 of these Tesla batteries in a typical Tesla, but not many people know this is really an empty can. And actually, the real innovation is in this what's called a battery film called an electrode.
Okay.
So, taking what they do right now is they take these battery powders, they mix them in polymers, and they mix it with high temperature solvents. So, and then they coat it onto a foil, and then the solvents don't provide any utility. So then they use massive amounts of ovens to remove them. Think of like baking a cake. You need to, cure it and condition it. Our process that, what if you could just flash it with light? No ovens, no heat. You just instantly coat it and it cures instantly. And what that does is basically you can make this much faster. You can shrink the factory because now you're not talking about 80 meters of ovens to essentially no oven, and it uses no toxic chemicals at all. So that's basically the innovation that I developed out of my PhD, and then also working with partners at Oak Ridge National Lab. That's what started the company Ateios Systems.
How'd you come up with the name?
So originally we renamed it Ocella, where basically wanted, if you ever heard of ocelli, it's basically like hidden, which means like a owl eye. If you ever see butterflies, they have like a hidden owl eye. So the idea was to make I had this I read this very famous guy called Mark Weiser. He envisioned the ubiquitous computing. He was saying the most profound technologies are ones that disappear. You forget that they're even there. So that's kind of the vision we wanted to get, is to make technology so good you don't even know it's there, right? It becomes part of you, because improves your life without you knowing it. Unfortunately, that was a kind of a generic form of birth control, so we had to change the name. So that's a funny story. Um, but the really kind of the same vein of Ateos, it was that we want to build a tech oasis where I think right now the way devices work, it's all consuming, it requires all your attention. If your battery dies, right, everyone complains, oh, I need to go charge it. Our vision was, what if you could build a oasis of technology where it doesn't even need any human input, right? It works as needed, doesn't need to charge. That's the vision we want to empower, because technology becomes so profound you don't even know it's there.
Okay, now You have enemies, I guess, right? If you're doing this, because you're putting traditional businesses, companies out of business. How does it, who's trying to stop you?
I mean, from our perspective, everyone is trying to solve this problem. So the
I
whole
see.
Tesla was actually first mover in 2019 to
Okay.
adopt it because it dropped down costs.
Okay.
Actually, now what we're seeing is the European Union is now banning the chemicals that are used in traditional
I see.
manufacturing.
I see. I see.
So
I see.
there is a real push to move it. It just the challenge is that can you build a solution that can hit the production speed, the yield, and the quality in order to replace that? Because if you don't, yeah, you might have these benefits, but if you can't hit the same yield and production, those value props don't matter, right?
I see.
Because if I lose half my stuff while I'm making it, it's still, all those benefits are gone. So that's going to be the real challenge is can we get the same specs as traditional manufacturing? And then that'll allow everyone to actually enjoy those benefits.
Is your stuff super secret patented, or there's a bunch of people doing this?
So there's a bunch of people doing different approaches. Some people are doing spray, different types of polymers. Our process is using energy curable polymers. This is a technology that was developed at Oak Ridge. So I spotted it, I tested it among the others, and it was the most promising tech. It just worked out of the gate. All the other solutions were really difficult to work with, and so that's where I licensed it. And then, kind of part of the journey was after I did my PhD, I understood really I didn't have actual know-how to make batteries. So actually, I moved the company to Indiana, where we actually incubated in a $15 million battery pilot facility. And it was a unique approach because traditional battery startups is that they go to investors and say, "Hey, I have this really promising tech, but I don't know if I can manufacture it. Please give me $20 million to go build up a facility and prove it." And I'm going to demand a $100 million valuation in order to get that, right? So it's really hard to get a $100 million valuation when you're making no revenue and you don't know if your performance claims can actually scale, right? This is kind of challenges we've been seeing in the battery space. So actually, when I visited the facility in Southern India, I call this battery innovation. I noticed all the startups were outsourcing their manufacturing to them. They were doing all the core work, and so that kind of just light bulb was like, yeah, we need to move here. We need to move here because we can get access to the tools. We have supply chain, and our staff is going to get developed much better. And it's proven to be much, a game changer, right? Where for less than $3 million, we have production grade product out in the market already. So, and that's unheard of in the space.
Gotcha. Where are you? Yeah, where are you in the life cycle of the company? Are you how far down the road are you with people, revenue? You still, give us a general overview.
Yeah, sure. So we're a team of 10 right now. We had our first initial seed round back in 2020 that was led by Good Growth Capital. Now we've actually been consistently generating about 1 million of revenue per year so
Great.
far on DoD and commercial contracts.
Great.
We have now released our first rechargeable battery product. It's already in production, and now we're raising money to scale it up, where we have customers who want to buy gigawatt hours worth of batteries, and we need to build out now we have to build out the facility to go fulfill those orders.
Why do you have to build out the facility? Why not just have somebody manufacture this stuff for you?
Yeah, actually, you hit it right on the nail. So actually, what we're doing right now is we're leveraging what is called a fabless or toll manufacturing. So we're working with partners or toll manufacturers to retrofit their process with our technology. So we have to make a little bit of investments with our technology to in order to get that. So instead of raising $30 million to build a whole line, we just have to put in 1 million or two, and we can retrofit that infrastructure.
Gotcha.
So and
What, gotcha. What's the DoD buying from you? What are they buying? What's the finished product they're buying?
Yeah, so actually, that's another side story. Uh, Army Research Lab actually developed a really cool solid state electrolyte that basically, when it gets shot at, it doesn't catch on fire. The challenge is that they couldn't, it wasn't compatible with existing manufacturing because of all those reasons that I mentioned. So they reached out to us. They said, our technology was very compatible. So we demonstrated initially some cells. There's a YouTube video where we delivered 1 amp hour cells to them where they could shoot it with 50 caliber bullets and it still powered the device compared to traditional tech where it'll either smoke or catch on fire.
Uh,
So, so once we had that contract, we got additional 2.4 DoD to start now building it up to scale, prioritizing a domestic supply chain because 90% of batteries are manufactured from Asia. So not only do we have to provide that safety solution, but we need to do it with domestic supply chain and hits performance specs at the same time. So that's
Why do you have to do it domestically? Because it's DoD and they don't want anything from somewhere else?
yeah, I
Yeah.
mean, think of the bullets, right? I mean,
Yeah.
each soldier carries 16 pounds of batteries. If my adversary is providing all the bullets, then I'm basically, out of luck, right? So, yeah, so that's the batteries are so critical to the effective strategy for the
Okay.
DoD, especially in
You,
modern warfare now.
you said 10 people
Yeah, 10 people. Yep.
and you're doing 1 million in revenue with 10 people. That's pretty good. So your
Yeah,
overhead's pretty,
we did 1.8 last year, and we're roughly at 1 million this year. So we had some decrease, but that's
why?
uh,
What happened with the decrease?
just it's just a kind of drop down in our DoD contracts. So just it was front loaded, and then a lot of our DoD contracts were front loaded.
I see. Well, who are you? Who are you? But you said earlier before we started recording that you got a bunch of new orders in and now you got to scale up manufacturing. Is that right?
Yeah, yeah. So that's for I'm saying for this year we'll probably
Yeah.
be,
Yeah.
end of the year,
Yeah.
probably. What we're doing now is we've got additional grants from the NSF. We've got additional grants coming. We've got another DoD contract that was awarded as well. So we're supporting those. And then secondly is now that we've released this high energy density product for consumer wear application like laptops, gaming controllers. We're now hitting their specs and now selling our electrodes to partners in Asia to supply those customers as well.
What do you think you'll do in revenue in 2025?
2025, it's a chicken and egg. This is where we need a little bit more investment to go fill out those customers. We're going to try to manage as we can, but uh, right now from our partners, we can produce about $400 million in the next 2 or 3 years and up to maybe multiple billion in the five.
Wow. Okay. What's your current raise? I forgot to ask.
So we're actively raising 8.5.
Okay. And how
Uh,
much have
that,
you raised total so far?
yeah, we raised 3 million in dilutive capital.
So you've raised three and you're raising 8.5 on what valuation?
Say I take market comps we've seen roughly at the 30 million pre-valuation. At the point is really looking for a investor that can bring value as we're, trying to build up manufacturing lines here and then also potentially setting up facilities in Asia. So really looking for that investor who knows how to work on those multiple continents.
Are you hoping this 8.5 comes from one? Are you looking VC or what are you looking at?
No, mainly VC. I mean, we'll look at valid add investors like angels as well. So we're not shy to that. I think what I'm saying is that for the lead investor who sets the price of the round, we're looking for that to actually have a manufacturing background because that's going to be our core, especially
Good. Yep.
international. Well,
Yep. Good move. Yeah. Totally. I totally agree. Do you mind me asking, will this 8.5 that'll remove you from being the majority holder, I'm guessing?
no, I've invested significantly myself. So
So
yeah,
even after the 8.5 raise, you're still in control?
I don't know if I'll be in control, but I think I don't know if I say I don't I to be honest I don't know. I have to run the math. So, but I invested significant portion as well.
So
So
you have majority control of the cap table today.
yeah, today, yeah. So
I got you. Okay, good for you. Um, we can talk offline. Oh no, so that 8.5, that's where you hit the. So here's why I'm bringing this up. Um, it's that magical moment. I don't know if magical is not the right word. It's that moment where you're like, oh, cool, yeah, I'm gonna raise all this money, but I just am no
yeah,
longer actually in control. Not, I
yeah,
kind of am, but kind of not.
yeah. I understand. There's always that what is that or horror stories, right? The investor.
Yeah, yeah, yeah.
Yeah, yeah. I'm aware of it, but like my goal is to get the technology out and have that impact. So if
Good for you. Good for you.
if if there's like I've told my team, I always tell the same thing with my team, right? You're not entitled to the position, right? So just because I'm CEO today doesn't mean, I get to be CEO for a company that's going to be managing 100 people, right? So you've got to earn that position. So that's my attitude, where I want to get this company to be on its own, right? It doesn't need me or anyone to sustain it. It can build itself and build products by itself. That's the dream. So that's the goal.
I like that. That might be the highlight clip of the. I always do a highlight clip of these interviews. That's a good one. You've taught yourself how to be CEO along the way here, right? There was no You didn't go to school. You didn't get any training to be CEO. You've learned how to ride that bike on the way up here.
At the hard knocks, right? So yeah, yeah. So
Uh,
I've got a
yeah.
combination. I think what's been really helpful is since I moved to the Battery Innovation Center, my learning of batteries just accelerated. Like I can tell you, I did a PhD in the top schools for battery, but just having all the systems, all the know-how already industry built there, my learning is so much faster. And I can tell you, like my staff, their learning is so much better. Like I've had people where we hired from working packaging boxes at Amazon, now a battery engineer after a year. So that place at the Battery Innovation Center has been huge for my development as becoming a battery CEO, not just a regular CEO, but understanding material science, supply chain, manufacturing, and then trying to sell all that solution together, right? So they've put me in a really good position with all that training, just from a technical cost. Like, I mean, it's so crazy. Like, we have all the pricing from China on their pricing. We can spew that out in real time to customers. That's just all that learning we've built to just accelerate the product development. And so, yeah, I think the way I look is like, just imagine like you planting yourself in a car factory, right? Like a Toyota's car factory, and you just get to observe it, and for 4 years, right? And you get to learn where all the inefficiencies in that whole process, and then you get to go solve that problem, right? And that's what that ecosystem is there, right? There's constant conversations of, hey, this is a big problem. Whoever can fix this will be game changing. And you get, our team then is like, okay, let's go solve that. Right. So that ecosystem, I really that's why I'm so a proponent of that is because my development has been so much significant and so is my team. And I do see it as the model for how we build startups. There's a little bit of not only trying to get my technology out there, but also proving that we can do batteries better.
Mhm. Yeah, yeah, totally understood. What do you enjoy the most about running a $2 million company, and what do you find to be the most challenging?
So I think the most challenging first is just managing people. Especially I think with my age, also trying to deal with people who have a far more experience, right? Trying to get them to focus on, kind of what are the goals. And then the second one is also getting a little bit younger people as well to buy in as well. So I think I'm kind of in the middle. So that's been a challenge there.
Okay.
From the best joy is just I think I'm a big solving puzzles. So when a customer comes with A, B, C specs, I want to come with the performance specs that hit it, right? And then do it on a production level, right? That's I think is the most joy is when you see, hey, yeah, I've hit the specs, but I can actually do it for a million of units, not just one, but a million of units and doing it price competitively. That's the real drive here. And and then constantly saying, okay, how can we improve it further on a price, power, energy, just continually innovating on that. That's the best part I love about this job.
You're definitely a scientist engineer, but I think my instincts tell me you've had to learn the other pieces of the CEO job along the way, but like you said, you've grasped them pretty quickly, I think.
Yeah, actually, I think my school, my undergraduate, they really ingrained that to us is that technology is really, it's really impactful only when it's scalable and it's cost effective, right? So I think I heard this one scientist saying is like a lot of academic is like, oh, let's find the rarest material ever. It becomes like my precious, and it gets into these famous papers. But if you really want a real solution, it actually has to be like dirt cheap, has to be abundant. And so I think that training really hammered where many times where my team's like, hey, Raj, we've got this really cool nanomaterial that can improve power. And I say, okay, well, how much can they manufacture? What's the price per kilogram? If it doesn't beat what I have right now, you don't even spend time on it. You can tell them, hey, hey, you have to hit this price point. Can you get to that price point? But that allows me to be a lot more efficient as well, right? We only focus on really scalable solutions and not trying to do too much.
How do you like raising cash and asking rich people to write checks? Is that fun?
I think the challenge is that rejection. That part is the toughest part of it. I know it's the sales, right? You just have to go through that process. And it could be just like you don't even know why, right? And I think that's the difficulty of trying to understand, especially when you're trying to constantly improve and you don't know why, it becomes really hard to figure out that problem. I think like best example, you look like baseball players, right? Their whole thing is dealing with failure, right? They hit the ball about less than 33% of the time. but they've got, they've got video, they can see analytics, they can see what they're doing wrong. In this job, it's, maybe I said something the wrong way, it didn't, present well, or I missed this connection. I think that's the hardest part of the job is trying to figure out, how to improve without any data to look at, right? And where to see the trends are. So that's the hardest part for this job.
You know what gets on my nerves the most about raising cash is, and what I hear pretty commonly is they always want to dissect these fantasy monopoly number projection stuff. Well, how did you get to this number? And how do you know you're going to hit
Right.
this and this and this and this? And they want to like dissect and debate these futuristic metrics. And the reality is you don't fucking know. Like you're like, bro, look, I'm kind of guessing here. Like, I don't want to argue,
Yeah.
do you believe in the idea? Do you believe in the product? Let's not get into semantics about this little number 6 years from now. Like, please.
Yeah, this is the challenge that I find is I tell this all the time with me and my engineers. I think when you wear a business hat, right, you're being very ambitious and optimistic of what can be done. But then when you're a scientist, you're going straight to the facts. So it's hard to like go, compete with two brains. Like sometimes I could tell like what I pitch is like, oh, we're gonna hit $1 billion revenue projection, right?
Yeah.
And then my engineer team is like, well, we've got this might hit this might fail. And I'm like, yeah, I know, but we will fix those things, right? And we will get there. So sometimes it's really hard because those are the two brains, right? There's that vision where you want to get there, and then
Yeah.
it's like, well, we haven't solved 10 of these problems yet. I don't know how we're gonna get that unless we get that. That is the part I struggle with. I admit that. I can tell because, I am a scientist trained, but then I'm also trying to hit a vision and they eventually got to come in the middle, right? Otherwise, if you're talking about real revenue, real potential, and I think that's the two things that I definitely struggle with. Yeah.
How many
Trying to
times
get
have
there.
you been told no so far?
Well, let's see. I think we tried to raise 15 million in 2020. That was about the VC cold. I think I calculated. I talked to like 100 VCs during that time.
Wow.
So
Well, you talked to 100. So how many decks did you send out?
I don't remember, maybe 200. You got to be like at least three or four times that. So, yeah.
And give some advice to the aspiring entrepreneurs right now. Did you send a teaser? Did you send a deck? Did you call? Did you email? All the above. Give some advice there.
What I've heard the most effective is the warm intro. So you definitely need to get some of your investors to make that warm intro. You can send as many emails as you want, but it's just really not going to get the traction, or you're just not going to get that meeting. And I think the second thing is you can probably get the meeting, right? You can get 100 no's, but how do you get to that yes? I think what you really need to do is not only have that really good deck, but you also need to have that financial model where you can show them, like proof where you can say, hey, look, this product in the market sells at this price because of my innovations. I can sell it at a lower cost or I can pocket that margin. You've got to prove that because at the end of the day, most of these VCs are, business minded financials. They might look at the deck and say, yeah, this is a really good vision and all that, but if you want to get them to a yes, you got to prove it in my perspective is the financial model. So that's why I put a lot of work in my financial model to show, down to the cent that I can, compete on a global level, from a price and a performance.
Good advice. That's a great clip. Yeah, I totally agree. Yeah, at the end of the day, yeah, you're right. You're right. It's most of the time it's about the numbers. I mean, even if it's a good idea, they're going to be like, yeah, cool idea, but
Yeah. Well, the point is, yeah, the person is who's saying this is the customer, right? So you gotta, if you're talking about real revenue, you have to look at a customer's perspective. Okay, I mean, Raj, if I'm gonna buy this battery, you got to tell me two reasons. Either it's giving me more energy or it's a lower cost. Simple, right? Can I do that? Yes or no? And you've got to prove it. And once you prove it, you got to say, okay, can you actually make it? Like we've had many times where they said, yeah, I tested 10 of your batteries, great, but I want to buy 100 million. And then you're like, well, I can't do that yet. I need to raise more money. So they're not going to wait because they're going to just say, okay, well, come back to me when you're ready, to make that work.
why not I just make them a partner? Just make them a partner. Have them invest.
Having them
And
is it's tough because they want to be able to see you can make 100 million units. So before they invest, that chicken and egg issue, right?
I got you.
So
Yeah.
because if they already have a solution, this is the perspective, is they already have a solution. maybe it's not good as energy, but they get it at a good price point and they get it the volumes. You have the potential, but you know, they still need the volumes and the quality, all the certifications. It's not like, think of a major company like, buying a device. They're buying a component is really critical for them for having a successful business. So you have to be just as good as your big companies. That's where we've kind of learned where we can leverage the kind of what is called the fabless, or if you'll just see what TSMC and NVIDIA does. I mean, how does NVIDIA become a huge, $1 trillion company when they don't even make anything, right? They leverage
The most valuable company on planet Earth.
they leverage the fabless model. They worked with TMC, which is the foundry who builds the chips for them, and they just sell it to the customer. So we're leveraging, I'm using my semiconductor background to build that model, probably one of the first in the battery space to do that, in order to not only have to avoid raising so much capital, but to get the product faster out to the market.
Okay, I want to ask you, so is your goal, who are you selling your end product to besides who all do you want to sell your end product to?
Yeah. So actually, right now, our goal is to make these films, these battery films. We can right now produce it at price parity, but we can provide higher energy and it's compliant with regulations.
And
So
you're
we
going to
just
sell
want
it to who? Who are you
to sell
selling
it
to?
to the battery films who will die cut it and put it in these cans and then sell it to an end user.
And who is that? Who owns the can? Who's the can company?
So can would be any battery OEM, like a Panasonic, LG, those guys who are making these batteries. What they do is they already take these coating mixing process and they take these films and put in this. All we're saying is, hey, instead of doing it yourself, you can just buy it from me. I have the production capacity. Tell me how much you need. You can buy it and put it in your product, and we'll provide more energy, price parity, and
Are you pitching to these battery companies right now?
yeah, we're actively right now. What's happening is, we're talking to major customers who buy these batteries. They're actually referring us to their partners to buy our electrodes. So that's our first goal. And then now we're talking to those major OEMs like Automotive OEM to build chemistries for them as well, paid pilots for that. So it's a lot more complex. There's different chemistries for different applications. So we've got one product established, about 30% of that market. Now we're trying to expand and at least get 85% of the market by end of the year, or at
Can
least
I
have a
ask,
product.
I'm gonna ask this next question, which may seem a little off, but there's a reason I'm asking it. Are you going to make the stuff you're making, will it go into batteries that are going to be in all these humanoid robots that are eventually going to flood the market that Tesla and Figure AI are going to put out?
Yeah, for our perspective is we have a manufacturing platform that can impact all batteries. So we want to be the film that goes in every battery. So drones, consumer
Autonomous
electronics.
robots, whatever, all of
Yeah.
it.
Yeah, so we want to be all of it. We can do it much faster, we can do it sustainably, and we can improve energy just through manufacturing. So that's the goal. I think we're kind of going is like, okay, just because we can do everything doesn't mean we should. We have to be really strategic. So what we're doing is we're focusing on applications that are very low risk, very high margins, like laptops, consumer electronics. Use it as a beachhead, and then go after, the EVs, grid stores that require a lot more sales cycles, like 10-year warranties. So, and don't get me wrong, I think a lot of people don't realize the consumer electronics is a huge battery space. It's actually the largest. There was even an article like BYD, even though they're known for their EVs, their side hustle is selling batteries to Apple. So, from our perspective, let's go make those batteries, generate real revenue, drive down costs, and we'll be in a better position to tackle the larger battery systems like EV and grid storage.
Why wouldn't these battery companies buy your product? Why wouldn't they? Why aren't they just buying it right now? I don't, what's holding them back?
So I think I mean, right now it's just what we're seeing is that we've only built the chemistry for different customers. So really, what I would say is, right now the major OEMs are focused on different types of chemistries, so we haven't gotten there yet. So right now we're focused on the OEMs that really use our chemistry now, but we are working with those larger customers to get those chemistries as well.
Okay. What's the plan? Exit plan.
Let's
What's your exit plan? Who buys you?
Buys. So basically, what we see the fast path to acquisition is our toll partner would probably buy us, where we've already set up a line with them. They can put two to two that, we're making significant money off the line, high, good margins, that they'll just say, okay, we'll just buy you, right? And then it gets, instead of us making it, it's them putting their brand on it and
What
commercializing. So that
what
would be
do,
the
what does Raj need to take home to the wife for this sale to happen? What's the number for you?
in terms. So basically, I see, if we can
I,
get one, no worries.
I was gonna say for you, what does your number have to be? What's your take home have to be?
Oh, take home. I mean, so for I mean, I don't think I would sell. I mean, my perspective, I mean, obviously I'll do what's best for the investor,
Okay,
but my perspective is we're doing so many innovations beyond what we're
you'll just hold the stock. You'll just hold the stock or whatever.
I just keep innovating. Whether it's Ateios or whoever moniker, I just want to keep innovating that problem, and that's what I'm going to do. So this is my vision is right now in the US, right? It costs $146 million to build a gigafactory. With our innovations, I think I can get that cost down to 20 million per gigawatt hour. And so that's what I want to go build. And however long it takes, I've allocated at least the next decade to go build that.
Wow. Okay. All right, my friend. What do you have to close this round to survive?
So it's tough. I mean, we are self-sustaining. I
I was just
think
about to ask you what your burn was. Yeah.
the burden's around 100K, and we've got about a million booked. So it's a little bit tight. I think the challenge is kind of like these customers want to move fast, and it's kind of like kind of we've got a
Fine.
ball in.
Invest. Fine. I would just tell them, I'm like, look, man, like,
Yeah,
I'll move as fast as you want. How much you putting in?
I think it's like it's all about timing, right? This is what I would say. It's all about timing. Yes, right now we have first mover advantage,
Okay.
right? And a lot of customers there. Yeah, I could manage and yeah, it could be a lifestyle business, but if we want this to be huge, where I'm telling you I want a huge Terra factor impact,
Yeah.
I I'm not asking for a significant amount of capital. I'm asking about half the capital of my competitors to go still do $1 billion impact. So
Yeah. I
I'm
don't
not
see you a lifestyle business for you. That's too boring. You want to do you want to do something way bigger, way bigger.
yeah. I mean, that's yeah, I don't want to do just $1 million contracts.
Nah.
It's fun.
Yeah.
Yeah. I want to
Yeah.
hit I want to like I said, I want everyone to use an Ateios battery or be empowered by an Ateios material. That's where I want to get to. And I could chug along and do it and have everything, but I rather go. This is what I would say. I remember one CEO, right? He's like, "Do you want to be king or you want to make money?" Right? There's those two simple values, right? And I want to make money, and we have a potential to make $2 billion off that production line. I just need a little bit of capital and then go execute, and
And
then
by the way, you need the capital. You said earlier, first mover advantage. I mean, like you're talking to your investors, like, hey guys, we got to go here. We got to move. Somebody else is going to jump on it.
right. There's going to be other, yeah. I mean, there's going to be other competitors that are trying to solve this
Sure,
problem.
sure.
We've got to take that foothold and then expand, right? And then take over. And then we become, as you said, the incumbent. Everyone will want to use our process.
Okay. Last question, because we're out of time. How are you making time for the wife and kids? And this you're traveling all the time. You're killing yourself trying to get this going.
Right.
Yeah. How are you making time?
Uh, let's see. Trying. I mean, I'm not making time, so I don't know if I should say that. Well, I mean, right now, I mean, the company is the baby, so
How old
that's
are the kids?
no, I don't have any kids, so
Oh, that's right. Oh, okay, okay, okay.
I would say the company is the baby. So it's that's where I'm putting my energy in right now. So
You still married, or did she leave already? She already packed.
I'm married, yeah. So
Just joking.
it's
I
funny.
just
I tell you, I moved her. She's grew up in New York City, so you have
no.
to imagine her convincing her to move to Indiana, right? So you know, I can tell you a couple times when she came over, she's like, I remember when she first was like, oh, look at the skyline, right? And she's like, there's no skyline.
She's like,
So,
she's like, let's go out to eat, and you're like, cool, let's go to Chili's.
that's about it. Yeah, that's the challenge right now in Bloomington. We've every restaurant now. It's kind of
It's so good.
no other options, right? So I mean, the travel makes up for it. So beauty is,
You took
yeah,
her to you made her move to Indiana, and then you're like, okay, you stay here. I'm going to travel around and raise cash and do the
that's right.
business. See you later.
Yeah, a little bit.
That's so good.
So, yeah, so,
Raj, this has been fun. Thank you for being on the Riderflex show, man. Wishing you the best of luck and congrats on everything so far.
thanks, man. Yeah, I appreciate the time. So yeah.